Hi YouTubers. Here we're showing you a picture of a 4 volt 4500 milliamp hour lead acid battery. They're manufactured in Vietnam. They're very cost effective, and I purchased these on Amazon for use at school with my students. This was a brand new one, and I popped the caps and the little black tab on the top and removed the small caps. I wouldn't recommend doing something like this at home. We're doing this at school, and I'll tell you why in a minute. But then I spend about 2 hours flushing out the system to minimize the amount of sulfuric acid, which is with the matte fiberglass, which you see in white. This is a very common type, sealed lead batteries of 4 volt type, these glass fiber mats. And try to flush and flush. Then, after about 15 minutes flushing with distilled water, I begin flushing with 10% sodium bicarbonate. And as I said, I put in time to try to minimize the amount of acid in there when we take it apart. And then I leave it soaking for 24 hours in distilled water. And then to take apart, and with a Dremel tool, circular saw, or a suitable type of saw, it's plastic casing, I go around and able to pry the top off. So you can see the configuration. As I said, it's a 4 volt battery, secondary cell lead acid. The configuration is such that there are 5 pairs of electrodes in each cell, and they're in parallel to boost conductivity and milliamp hour and current draw. And the 2 cells then are hooked up in series, so 2 volts and 2 volts gives you 4 volts. Now, we are taking this apart. One of my students is working on a chemistry senior capstone project because we're going to analyze the gray. There's the gray one. And it's about 5 by 7 centimeters. I didn't have calipers at school. It's about 1/10 of a centimeter in thickness. These are very nice areas, nice sized electrode areas for study. There's the gray, that's your elemental lead. And its partner would be the lead oxide. Now that's the one you do want to be very careful with. It's very toxic. And that's the lead 4 oxide. Now these are prepared with usually leady type paste. And we're going to pry off the glass fiber paper separators, and we'll clip off the electrodes and do scanning electron microscopic imagery. We also have micro X-ray fluorescence, and that's valuable because we can get down to parts per million of metal contaminants. And there's a surprising number of metals that can be found in lead electrodes: antimony, tin, manganese. I did a quick artificial intelligence search on this, and there's surprisingly 2, 3, or even 4 others that can be found. So we want at the part per million level with micro X-ray fluorescence. So we want to see what's found. These are very good cells, batteries for good value. And we're doing cycles of charge discharge with some of them, try to go to 100, 200 cycles, and then once again take it apart and examine the lead sulfate crystals. Hopefully they're small and it's the larger lead sulfate crystals that kill a lead battery. So we want to examine that. We're also going to study the glass fiber paper, analyze it, take a look at what it looks like at 10 to 50,000 times magnification. So as I said, I would not do this at home, and my student will be going on for graduate studies in energy storage. And the other thing we're going to do is put various thickness glass fiber papers. I have matte, I have what it's called filtration paper, glass fiber filtration paper. Glass fiber is essentially fiberglass, different porosities though. So I'm going to try a very thin one with a pair of these electrodes, see how it performs at the 2 volts. And then we're going to apply gel electrolyte, fumed silica gel with 37% sulfuric acid, which is basically what industry applies to these separators as your electrolyte. And we'll take the material that the student has made and apply it and see how it functions. And for the capstone, many students will want to see this, and hopefully it'll be an interesting presentation. I'll upload images and other information. I'm doing charging up with an E-load 1.1 amps to 4.8 volts, and then I discharge down to 4.0 volts. And affordable and very good introduction to a very important battery, the lead acid battery, which is going nowhere soon. It's served us very well. And of course, every effort must be made to recycle the lead. About 85 or 90%, I think, is. That means 10, 15% is out there in the environment. Thank you for watching, and we'll keep you posted on our research. Bye for now.